Hi guys, welcome back. This video is an introduction to calculations with percentages. In the first part, I go over how to convert percentages into a decimal form for calculations. The next part involves how to do calculations where there is a percent decrease versus a percent increase. It might be a little bit different from what you've learned in school because these are strategies for being efficient on the SAT and ACT, but also they're actually pretty helpful ways to calculate things in real life. There are a couple problems presented in addition to a side note about calculating percentages. The first problem is pretty easy and would appear early on in the math section. The next problem is a little bit harder and more typical of what you would see later on the SAT and ACT because it asks you to calculate the original amount versus the final amount. Let's get started. Let's talk about percentages. A percentage is a portion or a fraction of an amount that can be considered whole. There are a couple ways to convert percentages into a numerical form so that you can use your calculation. So technically, X percent is actually equal to X over 100. So for example, if you take 5%, 5% is actually 5 over 100, and this is actually equal to 0.05. You may have learned a method in school where you take the number and from the decimal point, move it over 2 positions. So in this case, you would get 0.0x. If we use 5% again, 5% is actually going to be 5, and then you move it over by 2 decimal points. So you end up getting 0.05, which is exactly the same number as the method on the left side. I recommend method number 1 just so that you can avoid making mistakes. For example, if I ask you what 1/3% is, what would you say? A lot of people would say 0.33. But this is actually incorrect. So what you have is 1/3 as your X. So then you have 1/3 over 100. Technically, this is 0.33 over 100, which ends up being 0.0033. If you were to do it the shortcut way, you would take 0.33 and from the decimal move it over 2 points to the left. So you end up just getting 0.0033, which is exactly the same as before. Let's go ahead and try some SAT problems now. Okay, we have a pair of jeans that originally cost $135. There is a 15% off sale. A sales tax of 9.5% is applied on the discounted jeans. What is the total amount owed? So first of all, we have a 15% reduction and then an increase of 9.5%. This is a math tip and also a shopping tip. You don't usually care about the amount that you're being reduced because you're not paying for that. What you care about is what you actually have to pay for. So for example, you're not paying 100% anymore, but you're also not paying 15%. You're actually paying the difference between the two, which is going to be 85%. So here you would take the original amount, 135, and multiply it by 85 over 100, or 0.85 if you remember how to do it shorthand, and then you end up getting $144.75 as the amount that you are paying. However, we still have to do the tax. So with the tax, it's an increase of 9.5%. First, convert the 9.5%. So we have 9.5 divided by 100, which is just equal to 0.095. Then add it to 1. So we have 1 plus 0.95, which is just equal to 1.095. The reason why we do this is we're going to take this number and multiply it to the amount that's actually being taxed. Now we have 1.095 multiplied by $144.75. So you really end up just paying $125.65. Okay, let's try a harder SAT problem. The final price for a book is $12.40 after a 7% sales tax and a 15% markdown. What was the original price? So this problem is actually pretty typical for SAT or ACT, where they just ask you to go backwards and find the original price versus actually doing the calculations and finding the final price. Let's talk about the percentages first. So first of all, you have a 50% discount and a 7% sales tax. Remember that the 15% means that you're not paying 100% for the item, but you're also taking off 15% off, which means that you're only going to pay 85%. 85% is actually going to equal 85 over 100 when you're trying to put it into your calculator. So this just equals 0.85. So we'll be using this number a lot. The other item that you need to calculate is the sales tax. So remember, the sales tax is an increase. So first convert the 7% into a form you can use on your calculator. So that's going to be 7 over 100, which just equals 0.07. And then remember to add it to 1. So we have 0.07 plus 1, which is equal to 1.07. So these are the two numbers you'll be using in your calculations. The easiest way to do this is actually to use the numbers that are given. So let's try answer B first. Answer B says that the original price was $13.63. So if you have $13.63, technically you're supposed to take only 85% of it as your discounted amount, and this is equal to $11.59. After the discount, you have $11.59 and you still have to pay a sales tax, so you multiply it by 1.07 and this actually equals $12.40. So answer B actually worked. This is the quickest way to do the calculations, but I also want to talk about it in a more mathematical form. There's a couple ways to do this with variables. Let's go in the order of operation. So say that the original amount was X and you had to multiply it by 85% for the discount. So 0.85 times X is just going to equal the sales price. Then you would take this amount and you would multiply it by the sales tax. So we would have X times 0.85, which is your sales amount, and then multiply this whole thing by the tax, which is going to be 1.07. And then this is supposed to equal the final amount of $12.40. So 0.85 times 1.07 is actually equal to 0.9095. And then that's equal to 12.40. Solve for X by dividing each side by 0.9095. And you should get that X is equal to 13.63. That's method number 2. The last method actually involves just going backwards with the order of operations. So basically you have Y amount that was multiplied by some sort of sales tax of 7%, and you ended up getting a final amount of $12.40. So if you divide each side by 1.07, you should get the sales price. So Y would equal $11.59. The next part is that you basically had X times the percent that you're actually paying for, and that was supposed to just equal $11.59 because that's the sale price. So if you divide each side by 0.85, you would end up getting X is equal to 13.63, which is exactly what the answer should be, which is answer B. Thank you for watching. I hope you found it helpful. Feel free to subscribe and like below, and comment on what you think might help improve the videos and any requests for future tutorials.